Good day, everyone. How are you today? Last week of this program, we studied variables. In Python programming, different types of data are identified as variable types, such as string, integer, float, and boolean, etc. Then, we looked at storing information in lists, tuples, and dictionaries. We also studied the operators that are used to perform operations on variables and values. Then we studied how to write programs to make decisions based on conditions. In other words, if, else, if statements. We also did some practice exercises. I hope you enjoyed it. We also covered for loops and while loops in programming to perform the same task repetitively as many times as you want. This week's lesson is file handling in Python environment. As we know, in a software program, a file typically refers to a digital container that stores data, information, or instructions in a structured format. File handling in AI applications is all about reading and manipulating data stored in files and writing data to a file. This week, we will study how to create a file. This can be done using a file creation function in Python. Open a file. This allows you to access the file for reading, writing, or both. Read from a file. This retrieves data from the file and stores it in memory. Write to a file. This stores data from memory to the file. Close a file. This releases the resources associated with the file. Creating a text file. We will first look at creating a text file. A text file is a type of file that is used to store textual data. Converting speech to text and storing it in text files is a common practice in many AI applications, including transcription services, voice assistants, voice commands, and more. It bridges the gap between audio data and text-based AI processing and enables a wide range of applications that leverage spoken language. To create a text file, we use the open myfile.txt w function with the file name as shown here. Now, you can run the code. The myfile.txt will appear on the column on your left. Now, let's write something to the file that we have just created. The following code writes whoever leads, the AI race will lead the future in one line, and welcome to the week 3 of the AI Club program in another line. To write to a new line in Python, you can use the \n character. This is called the new line character. The close command closes the file. Why is it important to close the file? To avoid potential issues and ensure your code behaves predictably, it's a best practice to always close files explicitly when you're done with them. Now, let's open the file to read the content in the file. Following code with R character is used to open the file in the read-only mode. Now, you can run the code to see the content. You will see the 2 sentences in 2 lines. The withOpen function is used to automatically close the file when you exit the block of code. The following code opens the same file, myfile.txt, this time using the withOpen function. As you can see, there is no need of a close function at the end of the code. Let's say that you would like to write or append a new line to the existing content in the file myfile.txt. The new line goes as, today, we are going to learn about file handling in Python. The following block of code uses A to append the new line. Now, let's print and see the text in the myfile.txt. As you can see, the new line today, we are going to learn about the file handling in Python, has been appended. Now, we know text files that are required in AI applications, such as storing text data after speech-to-text conversion in man-machine interactions. In this section of today's program, I will be explaining to you a list of file handling tasks based on a very familiar practical example of an artificial intelligence application. That is, recommendation systems used in Amazon, Netflix, etc. Such recommendation systems use AI to recommend you products and services based on your past searches and activities. Let's assume you have to create an AI-based recommendation system to recommend products for customers based on their previous purchases. First, we need to create the dataset for training the neural network. Usually, the JSON, JavaScript Object Notation file is used to create the dataset for training and testing. JSON module in Python makes working with JSON files straightforward. In this section, we will learn how to create a file. This can be done using a file creation function open in Python. Open a file. This allows you to access the JSON file for reading, writing, or both. Read from a file. This retrieves data from the JSON file and stores it in memory. Write to a file. This stores data from memory to the JSON file. Append data. Append the new data to the loaded JSON data or create new data to append. Close a file. This releases the resources associated with the JSON file. Creating a JSON file. First, we need to import the JSON function in Python. Please see the first line of the following code. The second line of the following code creates a JSON file named test.json. In the following, you see creating a dataset and then writing to the JSON file test.json. The dataset here is a list of 3 purchased items at an online mobile phone vendor by a customer named Michael. The data in the following code is a dictionary defined and contains a single key value pair. The key is customers, and the associated value is a list containing one element. Inside the list, there is a dictionary representing a customer's information. This dictionary has 2 key value pairs: name and purchases. The last 2 lines in the code write this data to the JSON file. Now, we have to run the code to store the data. The file is in the column on your left. You would like to open it to see the content. Now, let's read the data and print them. The following block of code reads the data and print them. Assume we want to add the purchase details of 2 new customers, namely Jennifer and Johnson, to the dataset. In the following code, the new data has been assigned to a string variable called new customers. Note that this string is in the list form that we discussed last week. The code that follows append the new customers to the existing data customers list in the dictionary data. Now, let's read the data and print them. The following block of code reads the data and print them. Here, you can clearly see that the appended data also printed. Let's say that Michael purchased a new item from the store. The purchased item should be added to the existing purchases list. The following code append the newly purchased item AirPods 3rd Gen to the purchases list. You can see a for loop that you learned last week. Here, the for loop is used. Can you remember that the for loop can be used to iterate over a list? In here, for loop iterates over a list of names in the list called customers to find Michael. And then AirPods 3rd Gen is appended to his purchases list. Now, let's read the data and print them. The following block of code reads the data and print them. Here, note that the appended newly purchased item is also printed in the Michael's list of purchases. Alright. We have now covered some important basics of file handling tasks required in AI applications. We discussed the simple example of creating datasets for recommendation systems using JSON files. It covered file creation, opening, reading, writing, and appending data. Even though only data in the form of string were involved in the example we discussed, it is the same codes that are used in other applications where other types of data, such as numbers, are involved. Next, we will take a look at CSV file handling. CSV stands for comma-separated values. Based on your experience, you may have noticed how accurate modern-day weather forecasting systems are. Artificial intelligence is heavily used in various forecasting systems. In week 16 of this program, you will learn model and test AI-based weather forecasting system. Let's assume you have to create an AI-based weather forecasting model to forecast the weather conditions in a particular location based on historical data. First, we need to create the dataset for training the neural network. Usually, a CSV, comma-separated values file is used to create the dataset for training and testing. CSV files are often used for tabular data storage due to their simplicity and compatibility with various AI applications. Similar to the previous sections, in this section, also we will learn how to create a CSV file and write or append data to it. Creating a CSV file. First, we need to import the CSV function in Python. Please see the first line of the following code. The second line creates a CSV file named test.csv. Let's say we want to enter the date, time, and hourly temperature dataset to the CSV file we have just created. We would like to have it in a tabular form where the first column is the data, second column is the time in hours, and the third column is the temperature in degrees Celsius. Note that the column names of the table that are date, time, and temperature have been entered as a list column names. Note also that the date, time, and temperature data have been entered in the form of a dictionary data. The last piece of code writes the data to the CSV file. This file we have just created is visible in the file list on your left on the screen. You would like to open it and see the content in it. We have just discussed some important file handling tasks, such as file creation, opening, reading, writing, and appending data tasks with special emphasis on text, JSON, and CSV files. Next section of our today's program is libraries. Libraries in Python are like toolkits that help you do different tasks in your code without starting from scratch. They contain pre-written code that you can use, saving you time and effort in your programming projects. First, let's take a look at Matplotlib and Pandas libraries. Previously, we stored some time and temperature data to a CSV file. Visualization of such data in a friendly format that is easy to understand is very important. Matplotlib is a Python library that helps you create visualizations like charts and graphs to display your data in a clear and meaningful way. Pandas, on the other hand, is a library that provides data structures and tools for data manipulation and analysis, making it easier to work with and analyze datasets in Python. So, Matplotlib helps visualize the data, and Pandas helps us get the data ready for our special AI tools to learn from and make cool predictions. Importing libraries to the workspace. To be able to use the libraries, you have to first import them to your workspace. The first line in the following code is the standard piece of code used to import the pyplot module from the matplotlib library in Python. Import, this keyword is used to include external libraries or modules into your Python code. Matplotlib, this is the name of the library you want to import. Pyplot, this is a specific module within the matplotlib library that provides a high-level interface for creating and customizing various types of plots and visualizations. As PLT, this part of the code gives the imported matplotlib.pyplot module an alias or nickname, which is PLT in this case. Similarly, the second line in the code is used to import the pandas library into the workspace with the nickname PD. The following code will read the data from the text.csv, that is, the CSV file we have created a short while ago. Now all you need is simple print data code to print this data. As expected, we have them in a very user-friendly tabular form. Now, would you like to visualize the same data in a different form? This time, in the form of a scatter plot of the data with time in the horizontal axis and temperature in the vertical axis. Take a look at the following code. First, the figure size has to be defined. Here, the fig size specifies the size of the figure in inches, width, height, and in this case, it sets the width to 8 inches and the height to 6 inches. The second line produces the scatter plot. Time in the horizontal axis and the temperature in the vertical axis. plt.show is a matplotlib function used to display the plot or figure that you have created. However, this plot is incomplete. Can you guess why? The reason is this. Someone who doesn't know the code and only sees the plot will not know what is in the horizontal or x-axis and what is in the vertical or y-axis. That is why we need to label the axes to complete a plot like this. Don't forget to mention the units, time in hours and temperature in degrees Celsius. Adding a title to the plot will further complete it. We also add grid lines to enhance the readability. Sometimes we would like to connect the data points with straight line pieces to further enhance the visualization effect. They are called regression lines. Note that we have added only one new line to the code. plt.plot code adds regression lines on top of the scatter plot. If you remove the plt.scatter line in the code, you will only see the regression lines. By replacing the plt.scatter line with plt.bar, we can visualize this data in the form of vertical bar chart. You can now try plt.bar. This will produce a horizontal bar chart. By replacing the plt.bar line with plt.hist, we can visualize the same data in the form of a histogram. Histogram shows the number of times each data value occurs. This also called the frequency plot. We have just learned how to use Pandas library to structure the data in the tabular format. Furthermore, Matplotlib library to construct a scatter plot, regression line plot, bar chart, and histogram plot. Data visualization plays a significant role in AI applications, helping AI practitioners make informed decisions and build accurate models. Numerous other AI applications require handling of large amounts of image data. For example, today's self-driving car technologies use deep networks and deep learning to reconstruct the vehicle's environment, train autopilot systems, and self-driving. In here, identifying the objects such as cars, trucks, pedestrians, traffic lights, etc. in the vehicle's surrounding environment is extremely important for artificial intelligence to make correct driving decisions. Imagine you're trying to train a neural network to identify objects from the surrounding environment. To do this, you usually have to provide the neural network with lots of input images of cars, trucks, pedestrians, traffic lights, etc., so it can learn from them. To make sense of this visual data, you need a tool that can help you display and analyze these images effectively. This is where Matplotlib comes into play. Matplotlib is a versatile Python library that specializes in creating various types of visualizations, including displaying images. In this section, we will learn how to load images, display images, plot multiple images as an array, importing libraries to the workspace. We are already familiar with matplotlib.pyplot. A variant of Matplotlib is matplotlib.image. Here, image refers to a category of files or data that contain visual information, typically in the form of pictures or graphics. In the following CodeMPG is used as a nickname. Now, we can perform tasks such as loading a stored image. We have stored an image of a car in a file named image1.jpg. We can display this. However, prior to that we need to load the image to the workspace. This requires us to use the pim.imread function as follows. Now, you would like to use the following code to display the image together with a title image of a car. Plotting multiple images as an array. If you would like to plot multiple images and visualize them at the same time, the following code displays 4 images in 2x2 array format. Displaying 4 images in 2x2 format requires plt.subplots code. This code creates a 2x2 image space. 0, 0, 0, 1, 1, 0, and 1, 1 specify the exact locations of the images. NumPy library. As we know, image classification is required in many AI-based tasks, such as self-driving cars, face recognition, etc. In there, neural networks are trained to distinguish between different objects in images. NumPy is a very useful library in Python that can be used to pre-process and reshape image data into numerical arrays, which are then fed into neural networks as input. For instance, a convolutional neural network, CNN, can learn to identify images of handwritten characters by utilizing NumPy arrays to perform matrix operations for feature extraction and decision-making during the model's training and inference phases. This we will learn in week 5. In this session, we will discuss how to import the NumPy library, create matrices, perform matrix operations, index arrays and slice arrays, apply functions element-wise, flatten a matrix. Importing the NumPy library. In the following line, we import the NumPy library and give it the nickname NP to make it easier to use. In the following code, we use NumPy's np.array function to create a 3x3 matrix and then print it. What is a matrix? Matrix is like a grid of numbers. For instance, in many AI applications, image data are stored in the form of matrices. In the following you see a very simple 3x3 matrix. Why it is called 3x3 matrix? This is because it has 3 rows and 3 columns. Now, let's see how to create this matrix in Python. In a matrix, each horizontal line of numbers is called a row. In our example, we have 3 rows, 8, 4, 3, -5, 6, -2, and 7, 9, -8. The outer square brackets represent different rows, and within each pair of square brackets, the comma separates the individual elements in that row. Similarly, the commas help us separate the values within each row, creating a structured grid of numbers, which is what makes up our 3 by 3 matrix. Now, let's see how to add 2 matrices. In this part of the code, first we're creating 2 3 by 3 matrices, matrix 1 and matrix 2. In the third line of this code, we're adding matrix 1 and matrix 2 together using the plus operator. When we add matrices, we add each corresponding element number together as you can see here. So, in result 1, the number at the first row and first column is the sum of the numbers at the same position in matrix 1 and matrix 2, and so on for all the other elements. Similarly, the matrix subtraction can be performed using the minus operator. Here, we perform element-wise matrix multiplication between matrix 1 and matrix 2 using asterisk operator. Element-wise multiplication means that we multiply each corresponding element in matrix 1 by the corresponding element in matrix 2. It's like multiplying each number in one matrix by the number in the same position in the other matrix as illustrated in the example below. In this part of the code, we're performing element-wise matrix division between matrix 1 and matrix 2 using np.divide. Element-wise division means that we divide each corresponding element in matrix 1 by the corresponding element in matrix 2 as illustrated in the example below. It's like dividing each number in one matrix by the number in the same position in the other matrix. Here, in this code we're printing the number located at row 0, the first row, and column 1, the second column, of the matrix. In this case, it's the number 4. We use this kind of indexing to pick out individual numbers from the matrix when we need to work with them separately. Understanding pixel values. In the world of digital images, everything we see on our screens is made up of tiny dots called pixels. In a grayscale image, the brightest value is indicated by 255, and the darkest value is indicated by 0. We use the pixel matrix to perform feature extraction. For example, please see the 28 by 28 pixel handwritten character image provided below. We have stored an image of a car in a file named car.jpg. Now, let's use the following code to load the car image and display it. We have used the same code in the previous lesson to load an image and display it. The following code is used to determine the size of the image in pixel values. Here, in the first line, we're extracting the height and width of the image and assigning them to the variables image height and image width, respectively. Then the print function is used to display the extracted width and height. Now, the image size is determined in the pixels. From the results we can see, it has 167 rows and 250 columns. This means the pixel matrix dimension is 167 by 250. Now, let's extract the pixel values from the image and print it as a matrix. The following code is used to extract the pixel values from the matrix and print it. The first line converts the image into a NumPy array and stores it in the variable image matrix. The print function is used to print the matrix. In many traffic applications, the number plate of a car is extracted by isolating the region of interest. Now, let's slice the number plate region from the car image. We can clearly see from the image the number plate approximately falls between the 110 to 140 height pixels and 160 to 220 width pixels. The first line of the following code extracts a rectangular portion of an image, defined by rows 110 to 139 and columns 160 to 219, and stores it in the variable submatrix. Then the print a function is used to print the sliced submatrix. Now, let's plot the corresponding image for the sliced submatrix. The following block of code is used to plot the image. Flattening. In neural networks, flattening is used to transform a multidimensional input, like an image, into a one-dimensional vector. It's like taking all the numbers from the matrix and putting them in a single line, one after the other, as shown in the example below. This is important because many neural network layers, like fully connected layers, expect one-dimensional input. In week 5 of this program, we'll utilize the flattening function to convert the 28 by 28 pixel handwritten character image into a 784 element one-dimensional vector, which will then be fed into the input layer neurons for training and classification. Let's flatten the 3 by 3 matrix. Here, we're using a method called flatten function to transform our matrix into a 1D array. Now, let's print the original matrix and the flattened array. Feature extraction using NumPy library. Feature extraction is a crucial step in data pre-processing for various machine learning and artificial intelligence tasks. It involves transforming raw data, such as images or sensor readings, into a more compact and meaningful representation. The NumPy library, a fundamental package for numerical computations in Python, can be used to perform feature extraction efficiently. Performing convolution using NumPy library. Convolution in AI is akin to pattern recognition, crucial for tasks like image recognition. It processes data in small chunks, detecting features like edges or shapes. This allows AI to understand complex inputs incrementally. In essence, it helps AI see and interpret the world. In the week 5 of this program, we will perform convolution to extract features from the handwritten characters. Convolution involves sliding a small filter, also known as a kernel, over the image's pixel values. At each position, the filter's values are element-wise multiplied with the underlying pixel values, and the results are summed to produce a single value in the output, which forms a new image called a feature map. First, import all the required libraries to the workspace. We are already familiar with Matplotlib, pyplot, matplotlib.image, and NumPy libraries. The following code imports these 3 libraries to the workspace. As similar to the previous lesson, we use the following code to load the image1.jpg and plot it. The following code extracts the pixels from the image and print it. This code creates a simple 3 by 3 kernel matrix, or filter matrix, for a convolution task. As we discussed, a kernel is like a small filter that is used to process an image. It's a matrix of numbers that slides over the image to perform operations like blurring, sharpening, or edge detection. Now, let's normalize the kernel. Normalizing the kernel to have a sum of 1 ensures that when it's used for convolution, the image's brightness remains consistent, preventing unintended changes. This code normalizes the previously defined 3 by 3 kernel. It divides each element in the kernel matrix by the sum of all the elements in the kernel. np.sum, kernel, calculates the sum of all the values in the kernel matrix. Now, let's perform the convolution operation. In the following code, in the first line np.zeros like image is used to create an empty, all zero, numpy array with the same dimensions and data type as the image array and assigned to an empty image called convolved image. In the second line, a for loop is set up to iterate through the rows of the image, starting from the second row, index 1, and ending at the second to last row. This avoids processing the border pixels, as convolution typically doesn't operate on them directly. Next, inside the outer loop, another for loop is set up to iterate through the columns of the image, also excluding the border pixels. Then, at each inner loop iteration, the code calculates the convolution at the current pixel, ij, of the convolved image. It does this by taking a 3x3 neighborhood of pixels from the original image centered around the current pixel, ij, and multiplying it element-wise with the normalized kernel. The np.sum function then computes the sum of these element-wise multiplications, which represents the result of the convolution operation. This result is stored in the corresponding pixel of convolved image. Finally, the convolved image matrix is printed. The following code plots both the original and convolved images as a subplot for easy comparison. You can clearly see the difference between the two images. Now, let's change the kernel matrix and perform the convolution operation and compare the results. Performing max pooling using NumPy library. Max pooling is like a helpful tool in AI, especially in picture-related tasks. It makes pictures smaller, but still keeps the important stuff. It also helps the AI ignore small changes in pictures, pick out the most important things, and learn about different things step by step. Plus, it prevents the AI from learning too much about specific pictures, which can be a problem, and it does all of this while keeping things running smoothly. We will apply this max pooling operation in the week 5 of this program for size reduction of the convolved images. Now, let's load the required libraries and load the image into the workspace. Now, let's define the pool size. The following code define a variable pool size and setting its value to 3. This variable is used to specify the size of the pooling window when performing max pooling. In this case, a pooling window of 3x3 will be used to select the maximum value within each 3x3 region of the image during max pooling. In these lines of code, we will prepare to perform max pooling on a previously convolved image. The first line gets the dimensions, height and width of the convolved image, assuming convolved image is a NumPy array representing an image or feature map. Next two lines calculate the dimensions, height and width of the pooled image. In Python, the double / is the floor division operator. It's used for division between two numbers, and it returns the largest whole number, integer, that is less than or equal to the result of the division. For example, 167/3 would result in 55, because 55 is the largest whole number less than or equal to 55.66. They divide the height and width of the convolved image by the pool size, which defines the size of the pooling window. This step reduces the spatial dimensions of the image, making it smaller. Now, let's perform the max pooling operation. The first line of the following code initializes an empty matrix called pooled image with zeros. This matrix will store the result of the max pooling operation. Its dimensions were determined earlier as 55 by 88. The following nested for loops iterate through each row and column of the pooled image matrix, as similar to the convolution operation that we performed earlier. Inside the loop, we define a region in the convolved image to perform max pooling on. This region is determined by start row, start call, and end call, which are calculated based on the current values of I and j, the loop counters, and the pool size. This effectively defines the 3x3 window in the convolved image that you are considering at each iteration. Finally, we perform max pooling within this defined region by using np.max to find the maximum value in that window of the convolved image. This maximum value is then stored in the corresponding location in the pooled image matrix. The following code plots both the convolved and pooled images as a subplot for easy comparison. You can clearly see the difference between the two images. Let's change the pool size and determine the image and compare. Performing statistical analysis using NumPy library. Statistical analysis is essential in applications such as medical diagnosis and autonomous navigation, enhancing AI's ability to interpret visual data. Here, we will see how to use NumPy library to extract the important statistical parameters from an image. We will import the required libraries first and load the image to the workspace, similar to what we have done earlier. This block of code calculates various statistical properties of an image. Here, we use the built-in functions in the NumPy libraries to calculate the statistical parameters. We simply use np.mean to calculate the mean intensity of the image pixel values, np.average to calculate the average intensity of the pixel values. Similarly, we can calculate the rest of the statistical parameters using the NumPy library functions.